two particles are connected by a light, inextensible string passing over a smooth, fixed pulley. We want to find the tension in the string and the acceleration of the particles when the system is released. If we consider first the particle A, its weight acts downwards, 5 times gravity. The tension acts upwards. Now consider B, the weight acts downwards, 3g, and the tension in the string acts upwards. This object is heavier, so we would expect the system to accelerate in this direction when we release it from rest. We would expect A to accelerate downwards and B to accelerate upwards. If we now consider object A and make an F equals ma equation for it, the resultant force acting on this particle is 5g minus t. This must be equal to the mass times the acceleration. We'll call this equation 1. Applying F equals ma to particle B, the resultant force on this object is T. Take away the 3g, so that's the resultant force, and that must be equal to the mass times the acceleration, giving us a second equation. If we add these two equations, 5g take away 3g is 2g, and the tensions will cancel, and we'll get 8a. This tells me that A is equal to g divided by 4 meters per second squared. Or calculating, it's equal to 2.45 meters per second squared. We can take this value and substitute back into one of the other equations to find the tension in the string. If we use equation 2, the tension is going to be 3 times the 2.45 plus 3 times g, which we know is 9.8. And this calculates to give 36.75 newtons. We're often asked in questions where we have used certain modelling assumptions. For example, light, inextensible string. The fact that the string is light means that the string itself has added no mass to the system. And in solving the problem, you can see that we've only used the masses of A and B. The string has been disregarded. Inextensible means that the acceleration is the same for both objects. We also have a smooth fixed pulley. This means that there is no friction at the pulley. This assumption has been used in using the same tension on both sides of the diagram. If the pulley were not smooth, the tensions on either side would be different, as some force would be required to turn the pulley.